Okay, good morning and thank you and welcome to the What's New and Interesting in CATIA V5 webinar. I'm Rick Reed, Senior Applications Engineer for Invenio, and we're talking about some interesting things in CATIA V5, some new things in CATIA V5, and some stuff that you've probably already got that you may not know about. Just going to start off with CATIA V5 knowledgeware. Knowledgeware such as design tables, power copies, and those sorts of things. Then I'm going to look at an overview of some of the new features in CATIA V5 R20, 5 and 6. Then we're going to look at unfolding surfaces and a little bit of sheet metal. And then Dassault have a special offer on this month on lights out machining. So we're going to look at some of the CATIA machining functions in not much depth. CATIA knowledgeware allows you to add various levels of automation to a CATIA V model. You're probably familiar with parameters and formulae. We're going to be looking at design tables, power copies, product knowledge templates. Not going to be looking at macro programming, but if you're interested in that, you can talk to us about it later on. What knowledgeware allows you to do is to capture either user or company knowledge, to reuse it over and over again so that you don't have to remember how it was done, just do it again. Get rid of variations, increase traceability, and reduce mistakes. Going to start off by looking at some knowledgeware stuff. I'm going to open up some models from the 3D Experience platform, which is one of the database systems that comes with CATIA V5 PLM Express. So I've now searched for and found my my design table part. So we're going to look at design tables. What design tables allows you to do is to take existing CATIA parameters or variables, or parameters or variables from a catalog, for instance, of parts that you might be reproducing, put them into an Excel spreadsheet, and then make up configurations of different sets of parameters that design a part, and then choose one of those configurations. So we choose configuration number 2, and that's a different shape. So it's essentially an L-shaped part. Notice in this case the hole, one of the parameters is activate or deactivate a hole. So you can have a hole there or not have a hole there. And because you're driving it out of Excel, you can even use Excel to have if the length is greater than this, then we don't want the hole. So deactivate the hole. If the width is the height, then change the length or the radius or the angle. So you can do it in the Excel spreadsheet, and you can actually use some of the smarts in Excel to do it. Because I've been using the 3D Experience platform, I just wanted to show you that not only are the CATIA parts, CATIA models, CATIA documents stored inside the 3D Experience platform, so are so can be and should be the Excel spreadsheet as well. So just logging in as me, and here you can see not only do we have the parts, but the Excel spreadsheets in various versions and releases. As I was preparing for this demo, they also get stored in the 3D Experience platform, and I can search for them and find them later on. Next thing we're going to look at is Power Copy. What Power Copy allows you to do is to capture features inside a part, either in solids or surfaces, or both. In this case, the feature is a blister, is a sort of a sausage-shaped blister on a surface. And what you do is you open up the Power Copy capture panel, and you capture that geometry and any parameters that you wish to reproduce. And what we're capturing is not just that shape, but we're capturing how that shape was created. If you're not using 3D Experience platform, then you save it into a catalog. If you are using a 3D Experience platform, then you store that Power Copy definition into the 3D Experience platform. I've just searched for a part that I want to, so I'm designing this part, and I would like to put a blister on this geometry. Note that the geometry is substantially different from the Power Copy definition, but it's still a surface and it's still got some points on it. And I want to put a blister that runs between points on a surface. So go back to the 3D Experience platform, find the workspace where I'm storing my Power Copy definitions. It opens up the Power Copy definition and extracts it. This is the Power Copy instantiation panel, and what Power Copy requires, and the one I designed, is 2 points and a surface. Make sure that the nipple is going to be on this side of the surface, not the other side. Go OK, and that geometry creation methodology is reproduced. The geometry itself is obviously slightly different, but it's a surface between two points on a surface with a fillet. Use the same Power Copy, this time changed a couple of the radii, different points, same surface, instantiate it again, and now I have any time I need to create that sort of surface on other surfaces, that's captured, that's stored, I can use it over and over again. The big brother of a Power Copy is a product knowledge template, where a Power Copy copies how a feature in a surface or solid part was created and reproduced that. The product knowledge template captures how a part or a product was created, and then it lets you instantiate that back into an assembly. So it's not just a feature, but it's parts or products. Design Table and Power Copy are part of all CATIA licenses. Product Knowledge Template is a separate license, but it includes a lot of other knowledge-aware tools such as rules and that sort of stuff. So you can embed rules, you can embed macros, so that when the part gets instantiated, it can react in lots of different ways and morph itself to generate any sort of geometry. So here I am creating the parameters that are required to be modifiable when the product knowledge template is instantiated. So this is a tooling fixture. It'll be a tooling clamp, and it'll be used in an assembly, in a tooling jig assembly. So saving the part into a catalogue, opening up the product where this will be instantiated, then go to the catalogue, instantiate the product knowledge template. The inputs are a point on the sheet metal part, an axis so we get the orientation position on the table so we know how big it is, change some parameters, and then the whole product gets instantiated and it morphs itself to suit the particular geometry. Use exactly the same product knowledge template again, same inputs apart from a different point on a different surface, change a few different parameters, and then that the product knowledge template assembly gets instantiated in. Same product, instantiated twice, but you can see through some rules, through some geometry changes and some parameter changes that it's actually slightly different, but it still reacts exactly the same way as a normal assembly would. It's associative, so when you update its inputs, the product knowledge template product gets updated. Okay, we're now going to look at some of the new features in V5R26. There's new features in Sketcher. 3D patterning has been introduced. Fillets and chamfer interface has been changed, and a few extra bits and pieces in there. And the extract propagation has been improved. In the Sketcher, there's more automatic dimensioning. Projecting of edges has been changed. We can do curvature analysis. We can now create generic polygons, and we can do multiple dimensions of offsets. 3D patterning has been introduced, fillets and chamfers has changed. So we're going to start having a look at the automatic dimensioning. So we're going into a sketch with the automatic dimension will turned on in the sketch tools. So now when we create a rectangle, for instance, and other shapes as well, the length and the width are automatically positioned as dimensions. You just double click on them and change them on the run. So this adds to the circles and corners and things that have already been automatically dimensioned. Creating a new sketch, just using a position sketch for fun. And I'm going to do a project from 3D. Up until now, when you projected from 3D, you got one edge that was just one thing, and you had to isolate it to be able to get the separate parts. So now you can see there's just two projections, and you can't delete subparts of them. Now when we do a project, we right-click and go select boundaries. Then each individual boundary is still an associative mark, but can be individually edited, deleted, and modified. A new addition in Sketcher is the ability to be able to do curvature analysis in the Sketcher. You do need to have the GSD functionality that does the same thing available, but now you can do it in Sketcher. So any curve that you're creating in Sketcher, you can put the curvature analysis on. It's dynamic and persistent. So as you make the changes, you can see the curvature. The graphing option is also available, as in the normal curvature analysis in 3D. And up until about this version, when we only had the hexagon, the polygon creation inside CATIA, in the Sketcher we can now create a regular polygon of any number of sizes, any number of sides from 3 to 99, I think. Either do it dynamically by dragging on the edge as you're creating it, or use the sketch tools to specifically put in the number of edges that you want. Okay. 3D pattern. So the user pattern's now been enhanced so that the not just a planar sketch full of points, which still works exactly the same, but we can have a geometrical set of points in 3D. Same user pattern function. So select the feature we want to pattern. And in this case, select a geometrical set full of points, and we get an instance of each of the objects, not just in a planar pattern, but now in a 3D pattern. We now have access to the collection of objects to be patterned as well. So I'm deleting those points from the collection of points. In this case, I'm selecting a geometrical set of axis systems. So in this case, geometrical set of axis systems, I'm also editing what's being patterned. So I'm adding the fillet into the set of patterns without having to stop and start again like we used to. Define one anchor as the default, and now not only have we got a 3D pattern, but we've got an oriented 3D pattern using a whole set of axis systems. The red dot to turn off individual instances still works exactly the same way. Edit the pattern and turn those instances back on again. So a really quite useful addition to patterning function, not just in 2D. The filleting functions have been enhanced. You can see that there is now a single interface for constant radius fillet, variable radius fillet, chordal fillet. The other fillets are still there, but those three have been incorporated into one. We also now have the ability to select a vertex to fill it on, not just the edges coming to the vertex, but the vertex itself, which just grabs all the edges. And the variable radius fillet inside the same function works in the same way. Chamfering function. Now you can chamfer at a vertex, and the option, so normal chamfer at a vertex, turn the corner cap off, and we get the chamfering up to the vertex like that. Click on more, and just create the corner chamfer. So it chamfers the actual corner itself without actually chamfering the edges leading up to the chamfer, up to the vertex. Sorry. The next function is a generative shape design function. So we're going to change the generative shape design workbench, and it's extract surfaces. They've added some new propagation functionalities where not only can you do tangency or point or no propagation, but the propagation can actually be controlled by the fillet radius of the faces as you move away from the actual surface, the face that you actually pick to extract. So this gives you much more control over what gets extracted, what faces get generated during the extract process. A couple of quick ones. There's a new STEP application protocol, AP242, which is a combination of the standard AP 203 and 214. Not 2013, but 203 and 214. And there's some new functionalities, well, a new export format for instead of just STL for rapid prototyping, there's now AMF, Advanced Manufacturing Format, which a lot of new 3D printers accept. Moving now to a couple of surface unfold functions. DL1 function, which is an add-on to generative shape design. So we're going to have a quick look at using the DL1 surface flattening. Going to use the 3D Experience platform to open up a part. So you can search, or I'm going to look at the ones that parts I've opened in the last day or so. There's multiple ways of searching in the platform, by name, obviously, by type, and by last time we used them. What the DL1 unfold function allows you to do is to unfold a surface. So here we've got it's actually extracted off a cube. So I'm going to unfold that surface. So you pick a surface to unfold, you pick a point as a reference and a direction. In this case, I'm also going to pick edges to tear. I mean, this thing can't be unfolded without actually breaking it, so I actually pick the edges to tear, because it's an actual, it's a single surface box, and then you can see that it gets unfolded. You can change the orientation. Once you've got an unfolded surface, you can actually transfer 2D geometry from the unfolded surface to the folded surface, or vice versa. So we've got a sketch, and I'm transferring it from the flattened surface onto the unfolded surface, to the folded up surface. So, and you can do that either way. You can have geometry on the folded up and transfer it to the flattened, or vice versa. The DL1 unfold surface, I'm going to make a change to the size of the underlying cuboid, which just shows that it's associative. The unfold surface works with ruled surfaces or unfoldable surfaces, but also works with doubly curved surfaces. So here we've got a doubly curved surface. I want to unfold that. So and pick the surface, pick up an origin point direction. Pick the plane you want to unfold it onto, and a point and an orientation. And what that's saying is that this surface is not a ruled surface. It can't be unfolded. It can be flattened by going to the options here and saying, no, it's not ruled. So give me a flattened surface. And because it's going to have to deform it, well, I'm going to change the orientation first, but because it's going to have to go and deform it, there is an option for showing how much it is going to be deformed. So you can actually display the deformation amount. Change to the material view, and you can see that it's showing by percentage the amount of deformation to actually achieve the flattening this doubly curved surface. In the same way that I did with the box, you can actually transfer geometry either from the flattened to the unflattened, or vice versa. So here we've got a sketch again. and I'm going to transfer that sketch geometry. Next thing to look at is sheet metal design, generative sheet metal design, not new, but it's used for folded and sometimes doubly curved sheet metal work and producing drawings for manufacture. I'm going to get an assembly out of the 3D Experience platform. It's an assembly which contains a car radio, and I want to build the frame, the chassis that supports the car radio out of sheet metal. Sheet metal design, you actually start off with setting up some parameters, which is basically the bend radius of the material, the default bend radius of the material, the default thickness of the material, and the default corner treatments. You then create what's called a wall, and here are me slightly sped up video just so we can get it done, creating walls. At any time you can unflatten the geometry, cut cutouts through the geometry, fold it back up again. There's a number of step pressings and stampings that are available. In this case I'm going to do a louver, create a sketch, choose the opening face of the louver. I want the louvers on the outside. You've got some familiar functions. Sorry. What I've just done there is skip forward a whole bunch of stuff just so we don't have to show you each of the steps. So I'm going to step through using the scan or define in work object. So wall, 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 cut out an edge, a flange edge, which I can change the size of. Come back anytime. It's generative, so I can come back anytime at all. Put little fillets on the corners. Use a profile to define a particular shape. Some specific shape cutouts. Use the pattern function to pattern multiple instances along the bottom. Back to the louver that I created, then use the pattern to pattern those. Some cutouts on the sides with some sliding attachment joints. Put some fillets around the corners. A pressing for some clearance or an attachment or a snap lock in fitting. Check for clashes, both in the unfolded and folded orientations, to make sure they don't clash with each other. Go back to the 3D Experience platform, open drafting template, and then use the specific folded view function to generate the folded flattened view of the drawing, or normal ISO views and front views as appropriate. The last topic is what Dassault is calling lights out machining. It's essentially just introducing the complete machining process that Dassault has in CATIA, and the ability to use it for the complete process through design and machining and simulation, so that you can then do the machining in a factory with the lights out, maybe. The CATIA machining functionalities allow you to reduce time because it's a single environment, as in all CATIA stuff, reduce programming time because it's integrated, and to allow you to simulate the process, validate the process, and then allow you to then set up sort of long late night lights out machining processes. The video now is basically just showing the CATIA machining process. So here we have a part in a machine and a tool that's been selected and a machining strategy. In this case it's a hard material machining strategy, some sort of helical approach, and it's just showing you the tool and the holder and the part, and it's going through each of the regions that's being machined, the strategy that's being used, and simulating that process. The simulation process can also simulate material removal. So again, the tool and the holder going through each of the processes, showing the material being removed. Different tools, different cutting tools, different checking tools, different probes, and those sorts of things can be introduced into the machining process. So you can simulate not just the machining process, but the simulation process. Not only can the material and the tool be simulated, but the whole machine. So the tool, the chuck, the machine, the bed, the fittings, the clamping, and the appropriate clash detection and those sorts of things can be simulated. So once you go through the simulation process at the full machine level, then you can simulate the whole process, look for checks, look for clashes, interference checks, those sorts of things. Once that's completely simulated, then you're satisfied that the complete process with the complete machine works. Then you can post that off and then run it lights out overnight. The CATIA V5 machining portfolio, comprehensive from 2-axis lathe machining, 3-axis prismatic machining. It lives inside the PLM Express portfolio, and here are the enablers, and if you're interested, then talk to us. Until the end of September, there is a special discount being run, but seeing as you may see this up September, please feel free to contact your CATIA Invenio representative as above, and we can then talk about what currently is available and get more detail of the sort of information that you need. Thank you for your attention. If you've got any questions, please contact any of the people that you can see on the screen at the moment, and happy to talk to you. We will be trying to run webinars on a much more regular basis. If you've got any topics that you would like a webinar, let us know. Thanks very much.